Hi, I'm Jeff McCartney, back again with the human brain and body. But before we get into this topic, I do want to point out there's some other videos I've been doing. If you haven't seen those, check them out. Kind of builds, this conversation builds on those videos. But basically this video I want to talk about how the human brain and how the human body work together. This is a generic high level. This is definitely not like anatomy or biology. This is conceptually and how we can potentially create algorithms that model this behavior. So a high level overview. Basically, we have a memory system that stores information or stores patterns from the input. So inputs happen, they get stored in the memory. Those memory patterns, when active, so based on an input, the memory system will activate a part of the memory and it'll create a response out to a desire system. Right now I'm calling it the desire system. I have no idea exactly what it is. I'm not sure if it's part of the memory, part of the brain itself, or if it's like an extra piece that happens. So to speak more about what the desire system is, so we have, so let's say I have a couple places or a couple things in my brain at one time. I want to watch TV. I want to go outside and work on the yard. I want to go hang out with the friends at the bar. I have these three things juggling around in my brain, and I'm like, well, which one do I want to do? Which one do I need to do? And the desire system kind of helps us figure that out. How it actually behaves, I'm not sure. I'll get into it a little bit more. But once it says this is the thing I want to do, it then creates an output. That output then affects the inputs into our body, our touch, taste, etc. Next slide. So that output is affecting our input, and our memory system then says, oh, my state's changed, which then affects the desire system. The desire system says, oh, okay, we're moving in the right direction, let's keep doing what we're doing, which outputs again, which gives us new input, which feeds into our memory, and this loop just keeps going and going and going until our happy place our happy place is reached, and our desire system says, okay, we're good. We've achieved that thing that we were trying to achieve. We moved, our inputs eventually have gotten to a state that are positive, and our outputs slowly nudge them along. And our memory system is tracking these events and saying how close we're getting to something. If we're getting closer, if we're moving away, that's what the memory system is doing. So our inputs are a little bit more complicated than you might think. So initially I have just outlined, touch, sight, taste, and sound, the four of the five senses, because smell, I'm not sure is distinct from taste, but that's another debate. So these are what are being fed into the system, and our memory system is saying, based on these inputs, what are some outputs that I can do? And outputs are potentially inputs as well. So we might have both an output and an input, and we'll talk a little bit more about that later, but I just want to kind of put it out there. But the next slide, I'm adding a little bit more detail. So emotions are input, and also the temperature state. Now, this isn't a complete list. There's definitely a lot more to the input system. I mean, we have like 100 muscles, 100 or 1,000 bones. I don't know. I'm not a biologist. I don't understand human anatomy at that level. But there's definitely a lot of information being fed into the brain, into our memory system. And emotions are probably the biggest, most important piece of information that's being fed in. So you have anger, you have happiness, you have sad, you have lonely, you have boredom. So boredom is probably the one I focus on the most when it comes to this algorithm. How do we figure out that we're bored? The system, the body, and this goes back to the body, these things are very tightly integrated, the brain and the body. Psychology talks a lot about if we separate the mind from the body, can we still exist? And while the argument is probably yes, we can still exist, but if you put yourself in a sensory deprivation chamber, if you eliminate all stimulus, all input, you can't do anything. And if you can't do anything, you can't learn anything. If you can't learn anything, you can't experience anything. If you can't experience anything, what are you? You may be alive, but you're nothing. And this is from the concept of you have no experience. Let's say I was born, and not born in the sense I was grown in a womb, and the time I'm in a womb I'm experience life, but more in the sense of poof, I'm in existence, I'm turned on, and my memory is completely empty, and I have no input. I have no sensory input, and I have no ability to do output. And this goes back to computer algorithms, because that's the world they live in. A neural network, a belief network, any of those algorithms, they exist in nothingness. And how do you do anything, or how do you know anything if you live in nothingness? While you may exist, you may be alive, you can't do or experience anything. And so we really need this connectivity. We really need to be able to interact with our world, to be able to learn or experience things. And so all these inputs that our brain is receiving allow us to perceive the world around us. And by perceiving it, we can then try to change it. And we can change it by outputs. Outputs by saying something, by touching something, by moving ourselves from some place to another. But emotions are ultimately the thing that actually drives us. And so, let's say I'm just sitting here in a white room with no windows and nothing is happening. No sound, no visual stimulation. The temperature is just in the middle. I'm not cold, I'm not hot. For some reason, my body says I'm bored. I'm getting bored, I'm more bored, I'm bored. Why am I bored? Well, there's probably a simple connection between all the inputs and a chemical balance saying this is boredom. It's easy to say that, I'm agitated or I'm angry because of some chemical level in our body has gotten high. But saying I'm bored is a little bit more complicated because it's relying on the sense that our chemical levels are flat. Our baseline, or not flat, but baseline, they're in the middle, they're in the mean, and we're not really experiencing anything new. And maybe that's where it comes from right there, is that our brain isn't experiencing anything new. So the brain itself has become stagnant, and the brain's response to that stagnant behavior is an increase in chemical stating boredom. And another one that's easier to recognize is hunger. Hunger isn't really an emotion per se, but it is definitely an internal feeling, as opposed to one of the direct sensory inputs that we know of. And so our brain says, hey, this is going on, this thing, hunger or boredom, we need to do something about it. And so the desire system says, well, are there any known outputs? And the memory system says, no, there isn't any known outputs. So the desire system says, well, do something random. So the desire system says it does something random. That changes the outputs. Did the outputs change to a good or a bad state? Store that result, store that output, store those new inputs into the memory system, and iterate through this process until we get to somewhere where we're successfully overcoming our state of boredom, or we're successfully overcoming our state of hunger. And this is the very high level of how this thing works. And so how does it actually okay, let's start drilling down into this. And so the next slide, we're looking at it's a different way of perceiving what I just explained. And I'm trying to come up with a better way to explain this. This is the best one I have so far. But basically what's happening is we have our sensory inputs, we have our motor output, and then we have our brain, which potentially has the desire system in it as well. And so let's talk about just vision. So we put ourselves in a dark room and a quiet room, and we can't taste or smell anything, we can't touch anything. And what happens is that somebody puts a picture over our eye, and we look at that picture, and then they take that picture away. For a brief moment, our eye still sees that picture because the nerves along the eye are still stimulated, are still active, are still reporting to the brain that they see this image. So that goes into the brain. The brain stores that image because it's been seeing it. So it's like, okay, I'm storing it. But now the brain, or the stimulus or the image from the eye has been taken away. But the brain can still perceive it. So the brain then feeds that image out along the same nerves back to the eye. The eye nerves are now stimulated, causing you to experience that same image again. Now granted, it's at a faded state, it's at a lower state, it's not as strong as it was before, but it's now being fed from the brain as opposed to the real world. So you can still perceive and you can still see that image because the brain is stimulating the eye nerves. And that then gets fed back into the brain, and the brain shifts its understanding a little bit. And this then becomes an infinite loop of information. It's constantly being fed in new sensory information. The brain then regurgitates that information and feeds it right back out. Your eye can experience that, your ears can experience that, your sense of taste can experience that. If you ever think about eating something, you think about food, and your saliva glands start producing saliva, because to them they're getting an impulse from the brain saying, hey, food's ready, where there is no real food. You're not seeing food, you're not actually tasting food, but the brain is stimulating those nerves and saying, hey, I'm thinking about food, get ready. And the glands are saying, well, that's the same stimulus I always get, whether there's actual food or not. That's the same stimulus. And so the concept of remembering something is actually the brain stimulating those nerves to make you experience that same thing again. Now, granted, it's at a lesser intensity because it's the brain doing it, as opposed to it's actually stimulating those nerves. And I believe that every sensor has both an input and an output from the brain. The brain can stimulate any sensor, and that sensor can then stimulate the brain. And this creates this loop, this feedback loop with the brain and the body. But there are some things that might not feed back into the brain, and that, for example, might be your muscles. You don't actually feel anything when your muscles are contracting or expanding. And so maybe those are just one directional nerve system. So it just stimulates the muscle and that's all you get. But let's talk a little bit more about the brain itself. So now we're stimulating a nerve patch. And what I got here is a brain scan, an MRI scan of a person looking at or remembering a picture of a face. And so my understanding by studying MRI scans is that your brain is a network. And that network is tied directly to, your eyes, your nose, at different locations. So I'm gonna step through my slides a little bit here so I can talk about it visually. There's a lot of visual stuff that I need to talk about. So the brain itself is an actual network or graph, and so that graph then has as inputs each one of the sensors, or as an output your muscles. And the stimulation of those inputs are contained within various parts of the brain. So that MRI scan directly kind of maps to a graph or a network structure. And so when I'm hearing something, it stimulates the ear cells within the brain, the nerve. Okay, so the nerve goes from the ear to the brain and then stimulates a specific stack within the brain of neurons. And then that stack of neurons secondarily stimulates like your eye, because there's some overlap. You experienced at one point in time hearing that same sound with some visual event, maybe somebody's face, maybe the squawk. Oh, let's say a cat. Cat could be a good example. You hear a cat meow, and so that meow event stimulates part of the brain that is representative of a cat image. That cat image then feeds back out and stimulates the eye nerves, making you remember what a cat looks like. Also, a secondary stimulation could be the sound of the word cat. And so all these areas in your brain are these secondary things that are related to this primary input. If we could just completely isolate all your sensors and just feed you the sound of a cat meowing, these other areas would be related to other previous events that you have experienced, and they're getting stimulated at the same time. And that, going back to my previous slide, is stimulating the nerves on your eye, is stimulating your mouth to, or potentially your mouth, probably not your mouth though, but at least your ear to stimulate the sound of the word cat. And then also potentially, your muscles to pet the cat. And all these areas in your brain are being active, and those are feeding back out along the nerve paths to those sensors. And then, so let's jump off the cat concept for a second. I'm going to talk about the feedback loop a little bit more. So let's talk about a cheeseburger. So think about a cheeseburger. Now think about where you might get a cheeseburger. Now, of those locations, think about how to get to one of them. How do you get to one of those? So that process of you first imagining what a burger is, your brain stimulates that area of the burger where that's stored, which then feeds out along the nerve paths, stimulating related sensors, your eye to picture the burger, your ear to hear what a burger sounds like if a burger makes a sound, which it does now that I'm thinking about it, the crunching of the lettuce and whatnot as you eat it. So the action of eating the burger comes to mind. The taste of what a burger tastes like comes to mind. And that's all being fed back into your nerves so you can experience it. That output, that stimulation, then feeds back into the network, shifting the graph. So if you've ever watched an animation of an MRI, you can actually watch these patterns move around within the brain. And it's because the input-output loop of just the burger thought is feeding out along those nerves and then feeding back into the brain. And that feedback is shifting your understanding, shifting the graph. And if you shift it a little bit more by saying, now think about a location that you can get these burgers at. That's a secondary input to all these other inputs that are going on. That then shifts the graph way over to the left because that's where locations are. And you say, well, there's this location. And then you feed that out along the nerves. That gets fed back in. And that shifts the graph saying, well, that's too far away. So you go to the next location. And you say, that's close enough. And then I say, how do you get there? Another input into the system, shifting the graph again. And you say, you start to visualize the steps you need to take to get there. Well, I got to go out to my car first. I got to get in my car. I got to start my car. I got to drive my car. Well, if I take a left at this street, okay, if I go down this street and I take a left, every time I change context, every time I say, okay, well, I'm in my car, your brain says, okay, that's what I'm thinking about. I'm going to output the stimulus of I'm in my car, and then that feeds back into the brain, which then shifts the graph a little bit, and the graph says, oh, well, the next step is start the car. That gets shifted out along the lines, and then that feeds back into the brain, into the car, and then your brain is waiting for the next state, which is the input sound of the car starting, and then so forth and so on. So this is the high-level concept of where I'm at on how the brain and body work. I hope I've explained it in a way that makes sense. I hope this is a good understanding of how it works. The next conversation, I'm going to go into my actual algorithm that captures this behavior of at least the memory. I'm still working on the output of the algorithm, this flow that I just talked about. That piece I am still working on, trying to figure out exactly how that works. But the algorithm itself on storing this information, on creating this MRI pattern within a graph, I think I have down pretty well. And so that will be the next conversation. So until next time, I hope you guys enjoyed this, learned something. If not, if you feel I've left something out, or you might need some more deeper discussion on this, please leave some comments. If I got something wrong, feel free to point it out. We can start a discussion in the comments by all means. But until next time, I'll talk to you guys later. Thanks.